Hello everyone, I hope you are doing great. In this tutorial video, I would like to talk about Tandem Solar Cell with COMSOL Multiphysics. Before starting, I hope you subscribe to my channel, share my channel to your friend, share your comments, like my videos, and help me to monetize very soon. Let us start it. I provided two papers of myself that you can download from Google Scholar, or you can contact me to send for you. The first, you can see that this is the simulation of high efficiency SnS based solar cells with S caps, and also the other one is comprehensive study of anomalous hysteresis behavior in perovskite based solar cell. I want to combine these two papers and build a two-terminal tandem solar cell with COMSOL. Okay. At first, I bring an example that 3D perovskite solar cell. You can see in this video. In this tutorial video, I provide this file that I simulate 3D perovskite solar cell based on this reference. Just see this video, these two videos, and then you can see this structure. Now I wanna add this new structure SnS based. Here we can use perovskite solar cell as top cell and SnS as bottom cell, or vice versa. It depends on your idea. But for example, I use the perovskite as top cell and SNS as bottom cell. Okay. Here we have ITO, ZNO, ZNON, SNO2, and SNS. I just go to geometry. I can add a new block. Okay. The maximum height must be the total summation of these thicknesses, 300 nanometer plus 10, 30, and this is about 1 nanometer maybe. 310, 340, and 841. You can use H, SNS, $841, for example. Let me check again. 841. Yes, it's okay. Nanometer. Or H total, maybe HT. Maybe it's better. I use HT. And the width and depth, I use the same as the above block. And also I can, I want to add in below of perovskite, and we must consider this fact. This block will start from 0 at this Z direction. And I must below of that in the same as HT minus HT, and look at this, you can see the HT in below of perovskite solar cell, and we can rename it as PSK top cell and SnS bottom cell. Okay, now we can add the layers. For example, we can name it as a parameter or just by value. I add from value 300 nanometer, 300 nanometer, 30 nanometer, 300, excuse me, 10, 30, 10, 30 nanometer, 1 nanometer. This is very low, but and SnS 500 nanometer. And then I talked about it. The last one is not important because the HT included the n-1 layer, and the last will be added automatically. Okay, and the SnS will add, and I just will select it. You can see I added from the top, and now you can see SnS must be at low, and then also we must add molybdenum and glass. Let me add it. Molybdenum is 450. We can plus 450 nanometer and plus glass. Glass we can arbitrarily use 300 nanometer. It's okay. Now I can add HT molybdenum here, glass is here. The below of SnS, I must add SnS. SnS is 500 nanometer, and then molybdenum is 450 nanometer. Okay, and the last will be glass. Okay, you can see this structure. This is the glass, molybdenum, SnS, and SNO2, ZNO, ZNOI, and ITO. Okay, we can add different material here. For example, I add, we can duplicate these. For example, I duplicate this HDL. I bring it here, and I rename it as the first is ITO. I rename it ITO. Nice. Okay, 300 nanometer. The ITO is here. And I must add the data. Band gap is 3.65. Band gap 3.65. the affinity is 4.8. And epsilon is 8.9. NC and NV is 5.2, 1E18, 5.2 E18, and 1E18, 1E18. Mu n and mu p electron and hole mobility is 10, 10, 10, and 10. And the density of donor density is 1E20. I can add the domains, doping, analytic doping as a donor doping. This is ITO. I rename it as ITO, and 1E18 it is the donor density. Excuse me, 1E20. Okay. ITO is now added, and I add the ZNO. I can duplicate this, bring it here as ZNO. I recheck the data. Band gaps 3.4, 3.4. Affinity is 4.6, 4.6. NC and NV 1E18, 1E19, 1E18, 1E19, and the mobility is 125, 125, and donor density is 1E17 per cubic centimeter. Donor, I can just duplicate this as NO 1E17. Nice. And I can just save. Don't remember that. Save it at each step. Tandem. Let's try here. Okay, we save it as 3D Tandem, and I can duplicate ZNO and rename it as ZNOSN. I can copy the name. The band gap is 2.7. 2.7. The affinity is 4.3. 4.3. NC and NV is 2.2 E18. 2.2 E18 and 1.8 E19. And the electron hole mobility 4.71, 4.7 and 1. The donor density 9.3 E16. E16, and the other layer is SnO2. I just duplicate this. SnO2, and we just must it can't be seen. The 1 nanometer is very low here, and how could we? Maybe we can neglect it now, and also we can just zoom on it to see that. And sometimes maybe we can use let me show you. I can use a view, and as automatic, by automatic view maybe we can see that. And just let me yes, we can now we can see that. This is ZNOS, and this is SnO2. By just automatic view of camera, just I use a view scale up automatic, we can see that this in this view modeling, and I recheck the data. The electron affinity is 4.5, band gap is 3.6, epsilon is 9, and I forgot for the epsilon of ZNOS. Let me check. It's 30. Excuse me. ZNOS is the epsilon is 10, and also ZNO it's epsilon is 9. Okay, I recheck the SnO2, and ITO also. ITO it's 8.9. It's okay. For SnO2, I check the epsilon, band gap, affinity. It's okay. 2.2 E18, 2.119. It's okay. 125. 125. Donor density 1E20. 1E20 donor density. E20. Nice. and I rename it as SNO2, and I save it in each step. Then we must add the SnS. Let me check the SnS. Can duplicate it and rename it as SnS. Okay. The band gap is 1.1. Band gap is 1.1. Electron affinity is 3.52. 3.52. Epsilon is 12.15. NC and NV is 7.5 E18. It was NC, excuse me. And we must recheck all of them again. And this is NV 1E19. This was NC. Oh, I must recheck all of the data. Must be vice versa for all of them. Okay. You can use Control X and Control V, and NV1, okay. The electron mobility is 100 and the hole mobility is 4. 104. And nice. And the last parameter is ND is 0 and NA is 5.7 E50. Must be acceptor E15. Nice. And I just leave the optical properties. Just I want to model with the arbitrary generation rate. It is important to insert the N and K of material that I talk about the optical properties of solar cell in this video. You can see that. And I just want to simulate the top cell and bottom cell separately to see what the results will be. Okay. Here I added all the data, and I must add 2 new contacts. Let me show you how we can add it. We can add we can duplicate semiconductor. Okay, I just duplicate the semiconductor. You can see semi 2 and semi 3 and semi 2. It is okay. And in order you can rename it as semi 1 and semi 2. It's okay. Now for each one of them, I just consider the related cell. For example, here we have 3 layers. Here we have ETL, HTL, and define generation, and I just disable or delete them. And I have FTO contact, and let me show you. We have FTO and AU contact for the first cell, and we can call it first cell. And for semi 2, I just add the bottom cell. We have ITO, and this I remove molybdenum and glass because these are molybdenum is a contact, not important for semiconductor. Just we need the surface, and the glass also is optical that we can calculate via microwave frequency and not concern in semiconductor physics. I just in semi 2 I remove the ETL, HTL. I delete them. I just add these 4 layers. This is ITO, ZNO, ZNOS, SNO2, and this was ZNS. Okay, and now for contact we have 2 contact. The first is, let me check. The first is the surface of ITO. We can rename it as ITO contact. And the second is I remove the 9. Excuse me, it must be this is ITO this is ITO contact, and this is molybdenum contact. Okay, we add these 2 contact, and we can add study 1, or maybe rename it as top cell. And we can duplicate it. I copy that and I add the study from study bar, and I add just new study, empty study, and paste stationary, and we call it as let me use a capital word at the first. Okay, now it's nice. Top cell, I just add the semi 1, and the bottom cell I add a semi 2. Okay, And now we can simulate each one of them separately. For example, I add and also we must recheck the mesh. For example, mesh 3 for the top cell, we can mesh top cell and mesh 4 or mesh bottom cell. Okay, and let me just for bottom cell I add the bottom cell let me check. I use a free tetrahedral. It's better use a sweep mesh. Free tetrahedral is not good for 3D simulation. It's better use sweep mesh. I use sweep for domain 1, 2, 3, and let me delete this. The first is, you can see that. Okay, and for bottom cell I just add the bottom cell 1, 2, 3, 1. I can add all of them and remove the 3 of that, and I build it as you can see. Maybe we could error, I don't know, but we try it. For top cell, I add the mesh top cell. In mesh selection, I add mesh top cell, and for bottom, I add mesh bottom cell. Okay, and now I just click on compute to see what the results will be. Very good. It is running now, and it is good news for us. Very good. Error bar is important, and it must be lower than 1e minus 4 or 5, and you can see it is good now. Very good. And after running, we can check the IV curve to see what the result will be. It must be similar to paper. Just see this video that was based this video. Okay, now I can just, this is the area, I just copy that, and I can bring the semiconductor terminal, for example I0, and I divide it, and it must be divided to this value. I change it to milliamp centimeter, and I add from top cell. Okay, nice. You can see the result is very good. 20.288 milliamp per cube per square meter centimeter. And just let me excuse me for that. Okay, we can check with the data of this paper. I don't know what is that. Okay, it is 20 milliamps. and 1.1, and it is the same. Let me I don't know why this was up here, but it's okay. This red line, and if this is okay for top cell, we can go to legend and use a manual legend for top cell. Okay, and now I just add the bottom cell and I compute it. I hope it's run. I don't know, because we have a very thin, and you can see we have a problem. We have a very thin layer SnO2 and it caused some errors. We can neglect SnO2. Let me disable it. I disable SnO2 and I just maybe it's okay now. It's okay. We must work on it because the data are very important, and just I use extremely fine. Okay, now I compute it again. NC, okay, which material? We have 1, 2, 3, 4, 5, and here must be 1, 2, 3, 4, and it's not good. Oh, its SNS must be here, and also here must be removed. ITO, ZNO, ZNOS, and ZNS must be there, and ITO, and nice. And now I remesh again. And there is no need to this layer, just we build selected and I choose a better mesh. Okay, and I compute it again. I hope it runs. It's okay now. It is running now. And now after running, we check the IV curve to see it is okay or not okay. We just use the same generation rate for the top cell, but we must change it. You can see this video, the optical video. And then we have a top cell IV, bottom cell IV, and we can use a series connection, maybe by handy code or just summation of two curves together. Let's just see the results at first. And the speed of computation depends on your system requirements and configuration that I talked in previous videos. Please see all of my videos. All of these videos are linked together, and sometimes I talk about something and maybe you confused about it, and you can just see all of them to understand what I meant. Okay, here I add a new global by duplicate, and in new global I add the data set from bottom cell and semi 2, and we can see the new curve as a bottom cell. Okay, we have a top cell and bottom cell, and you can see these two different behavior, and maybe it's better we use a series connection. We must extract the data by copy data plot to clipboard, for example by origin or by Excel or MATLAB. You can bring the data on that software. Okay, and this one I copy data plot to clipboard. Okay, XY, and it must be XY. If I plot them, you can see this behavior, and just I can okay, you can see the same results. Okay, and we can bring any code by set column values to write, for example, W column 2 plus W column 4, maybe 2 plus 4. Let me recheck again. W column 2 plus W column 4, and maybe if we can plot a new curve, and this is the tandem results. It is so simple, series connection, but just the simplest way I remember is that, and you can also see my SCAPS video about series connection. Okay, we simulate a 2-terminal tandem solar cell, and I hope you enjoy this video. Please like this video, share your comments, subscribe to my channel, because I see that 80% of viewers not subscribe to my channel, and really I work on this simulation and my content. I work at day and night to provide a good video for you, and the best way for me to income money from YouTube is that you subscribe and see my videos. Don't download them, and I hope you understand the situation. Have a good time, take care, goodbye.